let us understand the construction of cam profile today. As I discussed with the previous problem how to construct the displacement diagram for a given follower. Okay, so I'll just let me summarize with the construction of displacement diagram. In the given problem, the outstroke angle is 60 degree. After that, there is a dwell of 30 degree. Outstroke means when the cam rotates, the follower is going to perform the lift operation. It is going to move upwards. That is known as outstroke, which is given by 60 degree. After that, for 30 degree rotation of the cam, the follower is going to remain at the same position. So that is known as dwell, which is equal to 30 degree. And next they are given when the cam rotates by another 60 degree, the follower is going to perform the return stroke, and that angle during the return stroke is 60 degree. After that, again the follower is going to be under rest for another 210 degree, and the maximum lift is equal to 40 mm, and the given type of follower is a knife edge follower, and minimum radius of cam is 50 mm. So here, first of all, you are supposed to construct the displacement diagram, wherein you have to take some suitable scale. Along the x-axis, you are supposed to take the cam rotation in terms of degrees. For each 1 centimeter, you are supposed to take 20 degree of cam rotation. And along y-axis, you are supposed to take the lift of the follower, which is equal to 40 mm. I have taken 40 mm on y-axis. Okay. Now divide that outstroke region, which is equal to 60 degree, into 6 equal parts. After that, there is a dwell period for 30 degree. So 60 plus 30 it will be 90. Around that, it should be a dwell period. After that, it is going to perform the return stroke for another 60 degree. After that, again it will be under rest. So this is the outstroke of the follower, and there is a dwell, and here is a return stroke, and followed by a dwell. Okay. After dividing the outstroke and return stroke into 6 equal parts, I joined a line from this bottom to the opposite corner, uppermost corner, and I maintained a constant line so that it is showing the dwell period. After that, I have drawn again a straight line which connects from this uppermost part to the point to the opposite lowermost point. Okay, so again it is followed by a straight line, and here is this line indicates it is under dwell. Okay, so this line is representing the movement of the follower during outstroke, dwell, return stroke, and dwell. Now let us construct the cam profile by using this displacement diagram. Here, to construct the cam profile, you need first of all, what is the type of follower you should know. Here, the type of follower is knife edge follower. Again, for roller follower, the methodology of construction of the cam profile is different. So, for knife edge, we are supposed to construct the cam profile. Again, we have two types of followers. It may be radial follower or offset follower. Now, in this problem, it has not mentioned is there any offset distance of the follower with respect to the cam axis. So, we will consider it as a radial follower, assuming that the axis of the follower is passing through the axis of the cam. Hence, let us construct the cam profile for a knife edge radial follower. Again, as I said for radial follower the construction method is different, and for offset follower the construction method is different. Okay. Now the minimum radius of the cam is 50 mm. So let me draw a circle by using the minimum radius of the cam as 50 mm. Let me locate the center. So radius is 50 mm. Locate the. Here you are supposed to locate the knife edge follower. Since it is radial, the axis of the follower is coinciding with the axis of the cam. Okay. Now let us divide this 360 degree into parts as we are divided in the displacement diagram as it is given in the problem. So here the first outstroke angle is 60 degree. Let me measure an angle of 60 degree. Approximately I am measuring 60 degree, which represents the outstroke theta naught. Okay. Next, from there is a dwell of 30 degree. So again from here you are supposed to measure an angle of 30 degree. This angle should be 30 degree. After that again there is a return stroke by angle of 60 degree. So you are supposed to measure an angle of 60 degree. You are supposed to use instruments while measuring the angles. Next, the return stroke, last dwell period is 210 degree. Okay, so this is the dwell period. And here is the return stroke. Here is the dwell one. Okay, so as we have divided the displacement diagram into the 4 parts which is given in the problem. One region is the outstroke region, dwell region, return stroke region, and again followed by dwell region. So in the same way here also we have divided the 360 degree into outstroke region 60 degree, then followed by dwell of 30 degree, return stroke 60 degree, and dwell of 210 degree. Now in the same way you have divided this region into 6 equal parts, right? So here also you are supposed to divide this outstroke region into 6 equal parts. The angle is 60 degree. You are supposed to make it as 6 equal parts. So for every 10 degree you are supposed to keep a point. So 1, 2, 3, 4, 5, 6. Okay. So for every 10 degree I am using just approximate angles, but you are supposed to construct them with the help of instruments only. Okay. Let me name them as 0, 1, 2, 3, 4, 5, 6. As you numbered them here, 0, 1, 2, 3, 4, 5, 6. Same way I have numbered here, and you are supposed to draw thin projection lines which will emerge out of the beyond the base circle of the cap. Now, similarly, here also you have divided this return stroke into 6 equal parts. Here also again you divide this 60 degree into 6 equal parts. For 60 by 10. 60 you are supposed to divide into 6 equal parts. So every degree, for every 10 degree you are supposed to keep a point. 1, 2, 3, 4, 5, 6. So approximately I am showing the representation. So now it is 1, 2, 3, 4, 5, 6. Good. Again, you are supposed to draw projection lines. These projection lines must be as thin as possible. Right. Now, let me transfer the distances what we obtained from the displacement diagram into the cam profile. So 0 and A, they coincide here. I'll write it as 0, A. Fine. Now, you are supposed to measure the distance from 1 to B. Measure the distance from 1 to B in the displacement diagram and transfer them into the cam profile. Let it be B. 1 to B. You are supposed to measure 1 to B like this with your compass and then transfer the same distance with an arc. Now measure the distance from 2 to C. 2 to C and transfer the same with the help of a compass. Call it as C. Next, measure the distance from 3 to D. So 3 to D, draw a arc. Next, 4 to E, compass. Next 5 to E. Sorry, 4 to D. 0 comma A, 1 comma B, 2 comma C, 3 comma D, 4 comma E, right? 5 comma F. Distance, transfer the distance from 5 to F. Similarly, 6 to G. Transfer with the help of a arc. Now 6 to 6, again it's a 12 period. So same distance you are supposed to transfer, okay, and call it as H. 6 to H. Here you are supposed to name it as 6, 5, 4, 3, 2, 1, 0 for the return stroke. Similarly, here also let me write them as 6, 5, 4, 3, 2, 1, 0. Because here it is a forward stroke and here to here it is 12 and from here to here it is a return stroke. So I am writing 6 to 0. Next, 5 to I. Measure the distance from 5 to I and transfer the same with the help of a arc. Next, 4 to J. Next, 3 to K. 2 to L. 1 to M. And N. Lastly is the N. Okay. So we have transferred all the distances from the displacement diagram to the cam profile. Now let us join these points with the help of a smooth curve, freehand curve. This curve should be smooth and it should be freehand. You are supposed to complete this. This is how the cam rotates. Starting from 0, you are supposed to, as the cam rotates 360 degree, the follower moves in this path. Okay, for 60 degree rotation, out stroke, and here to here is 12, and from here to here is return stroke. After that, there is a 12 for 210 degree. This represents the